analyze part of functions, which is straight line. So this is a very important concept that needs to be understood. So when we are talking about a straight line, we are talking about a certain graph that is of this nature. It is linear. This is a straight line graph. So straight line graph is given by the equation of y equals to mx plus c. Y equals to mx plus c, or we can just say y equals to ax plus q. So the first thing that we need to check about our straight line, it is this point here. This point, which is called the x-intercept. X-intercept So when we are talking about x-intercept, we are talking about a point where the y equals to 0. So that is to say that we have a particular x and 0. So this is what we call our x-intercept. So let us now analyze another thing here. Let me use a different color. This point here. So the point is called y-intercept. So this is the point where x is equal to 0. So that is to say we have a particular x equals to 0 and y. So this is our y-intercept. So let us analyze this using our equation. If we have y equals to mx plus c, and then we want the y-intercept, that means when x equals to 0, we are supposed to substitute our x where we see the x variable. Then now we have x equals to m into 0 plus c. So that is to say y equals to c. In other words, the c on our equation represents our intercept. If we use the equation y equals to ax plus q, that is to say q represent our. So that is the first thing that we have to know. We have to know that where the graph, this graph touches our x-axis, we are going to have an x-intercept. When the graph touches our y-axis, we are going to have our y-intercept. So that is the first thing. So when we check this equation, it is y equals to mx c. So this is what we call a general equation or a standard form. So this is what we call a general equation of straight line, or we can just say standard form. So this is what you need to know. So another thing that we can analyze from our equation is our m. Our m is gradient. It's what we call gradient. So which can be given by changing y over changing x. So let us say we have maybe x1, y1, and x2, y2. So if we have these 2 points, we can now create our gradient as y2 minus y1 over x2 minus x1. So that is what we call a gradient. So we use 2 points that are on the line to get our gradient. And we also know that in another chapter, analytical geometry, which we'll see it in the near future, gradient can also be found by the tangent of our angle, something like this. So this is also gradient. So in our case, we are going to stick with m equals to y2 minus y1 over x2 minus x1 for this chapter. And then another important concept we need to understand, let us get back to our graph, is what we call a domain. So before writing our domain, let me try to copy. So it failed to copy. Let me just get back to it and then analyze it from there. So we are analyzing our domain. So with our domain, let us focus more on this horizontal axis, which is the x-axis. Domain has to do with the x-axis. So we know that we can have negative infinity on this side, and then if this is 0, we have positive infinity on the side. So this is to say we have negative infinity here, we have positive infinity here. So when we are talking about our domain will include everything on this. If we extend this graph, everything will be included on this side, on the left hand side of our 0, or on the negative side. The negative values will be included on our domain. So even if we extend our graph, the positive values will be included on our domain. So that is to say that for domain, we can say that it is negative infinity included to positive infinity included. So that is how we can write the domain for our straight line. Or we can write it as x is the element of real numbers. So this is how we write our domains. Shouldn't forget that our domain can be negative infinity to positive infinity where they are included, or we can write it as x is the element of R. So this is our domain. So the domain has to do with the x-axis. Let us now analyze what we call the range. So the range has to do with our y-axis. So this is our y-axis. Okay, let's say we have something like this. Is our equation, and then this is y equals to mx plus c. So now we are focused on our y-axis. So we know that we have positive infinity here. After 0 it is going to give us negative values. That means we can have negative infinity here. So when we extend this graph, real values or positive values will be part of our range. Even if we extend it on our negative side, the negative values will be part of our range. So that is to say that the range will be negative infinity included to positive infinity included. Or we can just say y is the element of real numbers. So that is what we call range for our straight line. So we have to know that in order to answer any question on our straight line. So these are the main concept about our straight line. So gradients can be negative and can be positive. So let me try to give cases on gradients. We've already analyzed how to get the gradient. Let us now just see the cases of gradients. So if you have a positive gradient, you are expecting something like this. You are expecting something like this. So this is how the graph will look like if we have a positive gradient. That is to say, if you have maybe an equation like y equals to 2x plus 3. This 2 is positive. We expect the graph to look like this. And then if we have a negative gradient, it is the opposite of what we have already discussed. So the negative gradient it will be in this form, the straight line. So it will be in this form. So that means we have y equals negative x plus 1, something like this. Our gradient in this case is negative 1. So it is negative. So this is how you will see that your graph is having the negative gradient. It can happen that the gradient be 0. So if the gradient is equal to 0, I call it a special case. We have something like this. So this is when the gradient equals to 0. You should always know this. And then it can also happen that the gradient is undefined. So that is when we have an equation parallel to our y-axis. That is when the gradient is undefined. Yeah, so with this information we can answer questions on our straight line function. So another thing that we can tackle is other ways to use a different color, other ways to get our equation or to write our equation. To write or maybe get our straight line equation. So we've started with the standard form, which is y equals to m x plus c. We can also write this equation as y minus y1 equals to m times x minus x1. So we can write it in this form if we know that the equation is passing through one point. We can also write it in the form y minus y1 over y2 minus y1 equals to x minus x1 over x2 minus x1. So these three equations will definitely give us the same answers. So any approach you use, you definitely have to arrive to the same answer. So let us try to remind each other things we have learned. So we use this when we are told that it is passing through 2 points. But when we have 2 points, we can use this equation. Any method you use here, you are definitely going to get the same answer. So let us recap on our straight line. This is how the straight line looks like. It has got the equation y equals to mx plus c, or it can be written as y equals to ax plus q. We have discussed about the y-intercept, the x-intercept here, and then we have discussed about the domain, where we emphasize that all the values, all the real values will be included on our domain. And we have also discussed about our range, where we have explained and elaborated that the values, the positive values and the negative values will be part of our range. We also have to take into account that the y-intercept means it is a point where x equals to 0, and then we have discussed ways to get our gradient, and that is all that we had to know on this